This is the second section, as it goes with your book. I want to show you a couple of things about how to use your book, also to check your answers, guys. I ask you a lot of times to try to do the odd problems simply because that's the ones that are back there. Sometimes they aren't back there, sometimes they are. But anyway, this first point is it says a sub 1 equals negative 2, a sub 2, a sub 3, a sub 4. Guys, your general term is right here. So guys, you look at that right there and you plug, if you would, you plug in 1, and so you'd have 1 minus 1. What's 1 minus 1?
0.
So 4 to the 0 is, times negative 2 is, and that's where that number comes from. So the next term, guys, the next term is plug in 2. And so you put a 2 right here. 2 minus 1 is 1 times 4. 4 to the first, or excuse me, 4 to the first is 4 times negative 2 gives me negative 8. Am I got a problem? So now the next number is plug in a 3. 3 minus 1? 4 squared? 4 squared?
Oh, 16.
Times negative 2?
30. Negative 32. 32. Negative 32.
Which is it? 32 or negative 32?
Negative 32.
Negative 32. Okay, so now 4. 4 minus 1?
3.
3. 4 to the third?
64.
64 times negative 2?
128.
Negative 128. Now, to show you guys, to show you something here, just to let you know, I want to make sure you understand this, guys, is this is an exponential equation. How do you know this is an exponential relationship? I mean, how do you know it's exponential? Guys, what did I just put it into? An exponential equation. That's called an exponential equation. So it's y equals a times b to the x is an exponential equation. The reason it's called an exponential equation is because the variable is in the exponent. This y equals x squared is a quadratic equation, and then y equals x is a linear equation. Okay, that's what you're going to be asked later in a second to do on some of the problems, and I think we're not real sure about how to do those. Guys, if I took 128 over 32, if I took 32 over 8, if I took negative 8 over negative 2, I always get the same number. That same number is 4, and it's called the common ratio. Anytime you have a relation that has a common ratio, that means that ratio is exponential. So 37 here, and number 37, again, a sub 1 equals 2. It asks for the next term, a sub 3, a sub 4. Okay, remember the standard form is a sub n equals a times a sub 1 times r to the n minus 1. That's the general term of a geometric sequence. Okay, so let's plug in one of these numbers. So the first number we plug in is 1. 1 minus 1 is 0. 2 to the 0 is 1. 2 times 1 is 2. That's where that 2 comes from. So what's the next number I'll plug in? Why 2? Guys, that's the second number. These are sequences, order of numbers. We only did explicit formulas. We didn't have to do any that were recursive formulas. We only did explicit. So the next number we take is 2. 2 minus 1 is 1. 2 to the first is 2. Times 2 is 4. 3 minus 1 is 2. 2 to the second is 4. Times 2 is 8. Take a 4, plug it in. 4 minus 1. 2 to the third. Times 2. And so there's your answer. Again, watch. 16 over 8. 8 over 4. 4 over 2. Doesn't matter. They always give me 2. Guys, that won't always happen now. Sometimes when you write 16 over whatever number this is, or 8, whatever that number is right there, you don't get the common ratio. You don't get a common number. If you don't get a common number, then that particular relationship is not exponential. It might be quadratic. It would have a second difference. It might be linear. It would have a first difference. And that's a question that you're going to be asked tomorrow. Okay, and then number 9 here, I have a 4, so a sub 1, a sub 2, a sub 3, a sub 4. When you plug in a 1 right there, that gives you 1/4 to the 0 power, guys. 1/4 to the 0 power, doesn't matter what it is 1 times 12 is 12. Now I plug in a 2, so it gives me a 1/4 of 12, which is 3. 1/4 times 12 is 3. 12 divided by 4, that's the same thing. Okay, so plug in a 3. 3 minus 1 is 2. 1/4 squared is 1/16. 12 times 1/16 is 12 sixteenths. 12 sixteenths reduces to 3/4. When I plug in a 4, 4 minus 1 is 3. A 4th cubed is a 64th. 12 times that is 12 64ths. And 4 goes into both of those. 4 goes into there 3 times. 4 goes into there 16 times. And it'll keep getting smaller and smaller and smaller. Questions here? All right, which of the following is a geometric sequence? So you want to look at it. You want to look at these 3 and see if you can pick out the one that gives you the same number over and over and over when you check it for a common ratio. Does anybody see the one that gives us a common ratio? In 44? I heard B. So 14 over 10, 10 over 6, 6 over... That's not the same number over and over and over again. D. That's D. What's 40 over 20? What's 20 over 10? What's 10 over 5? So it has a common difference. Which equation represents the nth term of the geometric sequence? Well, if you plug in 1 into all 3 of these equations, what should you get? If you plug in 2, what should you get? If you plug in 3, what should you get? If you plug in 4, what should you get? Which one gives me that? Which one? J? So that means if I come here and I say 1 minus 0, that gives me 0. Negative 4 to the 0 is 1. 2 times that gives me 2. So far, it's correct. So now I'm going to plug in a 2. 2 minus 1. 2 minus 1 is 1. Negative 4 to the first is negative 4 times 2 is negative 8. So it looks like it may be the 1. Taking a 3, that gives me 16. 2 times 16 is 32. So indeed it is J. Questions? Okay, it says the frequency of it is measured in hertz. It's called the pitch. The pitch is on a kid right there. What is the frequency of A7? So what I have here, guys, is I have some points. My points are 155, A2 is 110, A3 is 2. So I got to figure out what the nth term of this is. So it's A sub 1. Well, we know what A sub 1 is. 55. R to the n minus 1. So what we got to find, guys, is we've got to find this common ratio. So we should be able to take 440 over 220, 220 over 110, 110 over 55, and figure out what the common ratio is. 2. So A sub n equals 55 times 2 to the n minus 1. Now, does it work? How do you know what's 1 minus 1? What's 2 to the 0? What's 55 times 1? Okay, plug in a 2. 2 minus 1. 2 to the first. 55 times 2. Keep going, it gives it to you. What it asks for is the 7th term. So what number are you supposed to plug in? So to find the 7th term, you say 55 times 2 to the 6th. Where did I get 6 from?
7 minus 1.
7 minus 1. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. So you got 55 times 64. 55 times 64. So it's C. Questions, comments, how comes, what ifs? Suppose the depth of a lake can be described by a function where x represents the number of weeks of the day. Today, the depth of the lake was 334. What will the depth be in 6 weeks? Round your answer to the nearest whole number. Okay, so if 334, so y equals 334 times 0.976 to the, what is it, 6th? Is this an exponential growth? Eyes up here. Is this an exponential growth or is this an exponential decay? It's a decay. Look, 0.976. That's a number that's where? Less than 1. Remember that? That's what makes it an exponential decay. If that ratio right there, the formula is P times 1 plus or minus R to the T. Okay, that's your formula. 1 plus R is going to give me a number greater than 1 right here. 1 minus R is going to give me a number less than right there. So it's a matter of figuring out what 334 times 9.76 to the 6th is. So 334 times 0.976 to the 6th. I got 288.69. Round your answer to the nearest whole number, so it would be 289. Questions? Guys, it's this next question. When we were going through these, I don't think we got a good idea of how these work, guys. Again, the first thing that you have to do is you have to graph, guys. You graph y equals 1/3 to the x. So if I use a little graphing calculator here real quick to graph 1/3 to the x for me, and I want to do it to the x power, and I get, and what is this called again? It's right here, this though. It's a linear. That's an exponential decay. Guys, is it increasing or decreasing? Always decreasing, yes? Okay. Range. Y is greater than 0 or y is less than 0? Y is greater than 0 is the range. You said y equals 0. Y equals 0 is the asymptote, because that means this thing gets closer and closer and closer to 0, but never stops. Okay, and so, fine. So it gets closer and closer and closer to that horizontal line, but never comes to a stop. Now, to graph it on paper, guys, the first thing you need to do is you need to make the T-chart. And so to make the T-chart, you plug in the numbers -2, -1, 0, 1, and 2, so that you can see what this thing is going to look like. So that's 1/9, guys. That's 1/3. Any number to the 0 power is 1, so that's 1/3. That's 2/3. Then what happens, guys, in this problem is all of your y values get multiplied by -2. So these points, as these points stay right where they are, these coordinates, I mean, then 1/9 times -2 is -2/9. 1/9 times -2 is -2/3. 0 is -2. So guys, graph the point 0, -2. There's the point 0, -2 right there. Graph the point 1, -2/3. There's 1 -2/3 over 1 and down 2/3. And it's going to get closer and closer and closer. And so the picture is going to look like that right there. The graph is going to look like that right there. And what happens is it gets flipped and it gets made negative. So watch what happens when I do it over here. If I take right here, pay close attention to the red line. I'm going to put a negative in there and 2, and it flips it over upside down. Still goes through the y-intercept, still has a y-intercept, but this time now the y-intercept is -2. Questions?